There are two types of walls in Doom: solid walls, which are just normal walls, and through walls are so-called portals. These are walls with which windows, steps and other things are formed. And in this episode, we'll figure out how to render these walls, but for further work, let's first understand how it works in Doom. So we know that the two vertices form a line def, and the segments we render correspond to part or all of the line def. And here we introduce a new concept, side def. One line def can have a front and back side defs. They are needed first of all to determine the textures for the walls. There are three types of textures in Doom. Solid walls have a middle texture, and portal walls usually use upper and lower textures, and there are cases when all three textures are applied. The side def also has information about belonging to a sector, and a sector is another concept that we need to consider. Pay attention to this map. The entire area belongs to one sector, and sectors, unlike subsectors, can be concave. So with the help of sectors, we can determine the height of the floor and ceiling, as well as their textures. In the Slate editor, we can view this map in 3D mode, and in this case, all the walls are solid, since they belong to only one sector. This is called the front sector. And let's create a portal wall. This action splits our sector into two, and for example, let's change the floor and ceiling heights and start the render. So now we can see the portal wall, for which another feature is the presence of two sectors, front and back. Side defs and sectors are another lumps that we need for further work, and therefore they need to be read from the WAD file. And since we will talk about software rendering, which is not often used in modern realities, then the further narration will go in a rather concise form, and I will cover only the main points and algorithms. So, as mentioned earlier, we define classes for side def and sector instances according to their structures from the Doom wiki. At the same time, for convenience, we will add the appropriate attributes for the segment and line def classes. Also in the WAD reader class, we define methods for reading the appropriate data for these lumps. And in the WAD data class, we get all instances of side defs and sectors. And now it is important for us to correctly update the data. For each line def we determine the presence of front and back side defs by its identifier. But since the segments are given their direction, the side defs can be swapped. We need this information to determine the appropriate front sector for the segment. And if the line def is two-sided, then the segment will also have a back sector. To work with walls, you will need two classes. The first is the view renderer. For now it will have a method for getting a random color and a method for drawing a vertical line using the GFX module. The second class is the segment handler. From the initial attribute it is worth noting the current segment and the value of the angle to the first vertex of this segment. And do not forget to create instances of these classes in the engine class. And now, in the BSP class, we will pass the segments that ended up in the field of view of the player to the input of the segment classification method of the handler class. So, with this method we will determine the type of segments, and we will start with segments that do not have a back sector. That is, they will be solid walls, and here we will use the data of these segments in the method for clipping solid walls. In this method, we need to track how the horizontal screen space is filled according to the width of the nearest segments, and after the screen is completely filled with solid walls, we discard the remaining segments. And this task is from the category of range merging, and I recommend to understand how it was done in the source code. The screen shows this function of clipping solid walls in Doom. And in fact, here you can use various methods, or develop your own algorithm, which I did in my case. So, I did the following. On each frame, a set is initialized with a range of screen width coordinates. This corresponds to empty pixels along the x-axis of the screen. When obtaining the segment coordinates, a set is created with this range of values, and then we check for the intersection of these sets. Obviously, if the length of the intersection set is equal to the original length of the segment, then this is a new wall and it goes to rendering. And then we subtract this intersection from the original screen set, that is, these pixels are filled. But here it is required to handle the case when the new segment is partially overlapped by the previous segment, and then we find these gaps that divide the segment into several visible sections of the wall. And as an optimization, in the case of filling the whole screen with solid walls, we can stop further traversal of the BSP tree. And the corresponding attribute is used for these purposes in the BSP class, which is set to true when initializing each new frame. So, after clipping, the segment coordinates are passed to the input of the method for drawing solid walls, and at the moment we draw them with vertical lines. After running the program, we see flickering lines, but they are much more than just lines. And if we compare them again with the home screen when we launch Doom, we can now say with certainty that these lines correspond exactly to the edges of solid walls. And now our task is to figure out how to render these lines of the height we need. We will perform these calculations in the method of rendering solid walls. So, here, for ease of work, we will make some abbreviations for the names of variables. Here we need to get access to the textures of the wall, ceiling and floor, as well as to the value of the sector lighting level. Next, we calculate the relative heights of the floor and ceiling, taking into account the height of the player. And the height of the player is set in the settings file, and this value is an attribute of the player's class. And then, appropriate Boolean flags are defined to draw the wall, ceiling, and floor. And now we need to find out the height of the wall projected onto the screen by calculating the scaling factors for this, and let's look at how this is implemented in Doom. In the general case, we need to find the distance to the vertex and the distance to its projection on the screen, and their ratio will be the desired coefficient. So, in Doom, we first find the shortest distance to the segment in case the segment was an infinite line, and we took the direction of its normal from the player. A right triangle is formed here, the hypotenuse of which can be calculated knowing the coordinates of 2 points, and the desired distance is found by multiplying the hypotenuse by the cosine of the angle, which is also obvious how to calculate, since we know the segment angle. And the above calculations are given in the following lines of code. And the most interesting and unexpected thing is that we need to recalculate the distance between the player and the vertex. This is our hypotenuse, but using only the angles in the found perpendicular distance, that is, we use the polar coordinate system. We again calculate the desired angle, but only take into account the direction of the player and the x-angle, which we find from the corresponding lookup table that converts the screen coordinates into an angle. And so we can get the two required distances and find the scaling factor. So, as you understand, we need to create a lookup table that converts the screen coordinates into an angle. For this we use the arc-tangent function, and take into account that the middle of the screen corresponds to 0 degrees. And below is a method for calculating the scaling factor according to the above theory. Here it should be mentioned that for Doom textures the value of this factor should not go beyond the limit values. And let's get back to the method of drawing solid walls. When we have calculated the scaling factors for the two vertices of the segment, then using the linear interpolation formula we will find the step value for them. And with it, you can calculate the y-coordinates for the first vertical line of the wall, as well as their step values for the next x-coordinates. And it remains for us to iterate over all x-coordinates of the segment, and draw the corresponding vertical line. At the same time, at each iteration, we apply the calculated step values to change the y-coordinates for the next wall line. And at the moment, the name of the texture and the value of the light level are passed to the rendering function. This is done in order to form a hash of the texture name, and generate a color. Given the value of the light level, we do this once and put it into the cache of all colors. And finally, we can see a partial rendering of the first level of Doom. It's quite funny to see this level in this form, but on the other hand, a lot of work has been done to render the very first walls. Well, now for the full picture, let's deal with the rendering of portal walls. And for this we should return to the segment classification method. So, we know that solid walls are segments that do not have a back sector, but this does not mean that all other walls are portal. And therefore, the segments for which there is a height difference for the ceiling and floor are processed first. Then we discard the segments that serve as utility triggers and special events, and then we process empty walls, but the border of which changes the level of light or the textures of the floor or ceiling. For clipping portal walls, we use a similar version of the algorithm as for solid walls, with the only difference being that we don't affect the set of screen coordinates, because when we have a solid wall, we can't draw anything on top of it. And as far as rendering solid walls, it's like we're rendering two solid walls just for the upper and lower parts of the portal wall. After determining the relative heights of the floor and ceiling for the front and back sectors, we analyze the difference in these heights and the difference in lighting and textures, and based on this we can determine Boolean flags for drawing the upper and lower walls, as well as the floor and ceiling. And accordingly, this segment can be skipped if all these flags turn out to be false. Next, we use the same algorithm to find the scaling factors for the segment coordinates, and use linear interpolation to find the step value between these factors. And based on this we also calculate the y-coordinates for the entire wall, but taking into account the relative heights between the floor and ceiling of the front and back sectors, we calculate the y-coordinates for the upper and lower parts of the wall. And since portals are transparent, so you have to draw what's behind them, but we're drawing everything from near to far, and we need to be careful where we can draw on the top and bottom of the screen. And for that, we'll have 2 screen height clipping lists that we'll initialize on every frame, and with those we'll be able to keep track of every Y height for every X height on the screen. And a column is considered completely opaque if the height values of these lists are equal to each other. Areas where we draw walls mark the column as completely occluded, while portal fragments will only update the occlusion columns with what they actually cover in screen space. And using these clipping lists, the rendering of the walls will look like this. We start rendering from the ceiling, checking and getting the coordinates of these parts from the clipping lists, and after rendering the upper or lower part of the portal wall, as well as the floor and ceiling sections associated with it, we again update this clip information. And accordingly, we should check the clipping lists and select unoccupied Y coordinates in the solid wall rendering method. And ultimately we can render Doom game levels in a very peculiar cartoonish coloring. Of course, it was desirable to see the texturing, but even in this form, we can say that it turned out to be an entertaining level viewer. But as you can see, we simply fly around the level at the same height, and here you can use a method that will find the height of the sector in which the player is located, and make the appropriate correction taking into account the height of the player. And so we can now climb up and down stairs. And as we saw, quite a lot of work has been done to implement level rendering, and it was very interesting to find out what algorithms and techniques were used 3 decades ago. But we'll talk about the further loading of assets and how texturing is done in Doom in the next video.